Okay, so today we're going to solve 2D kinematics problem. For this type of problem, we have to be careful since the question has something to do with x and y components, which is horizontal and vertical velocities that involves with the initial velocity. So if you look at the question, it says a 1.5 kilogram projectile is launched at 18 meters per second. However, the launch angle is 26.0 degrees. So what does this mean? It means, if we draw a picture, it means that the initial velocity has angles assigned to it. And what will happen to vertical and horizontal component of the velocity? Well, there will be y component, which is Vyi initial, x component, Vx. However, for these types of problems, Vx is always constant. So, if you look at this problem, it says the initial velocity is 18.0 meters per second. So how can we find Vyi or Vx? Well, if you look at the trig ratio, so toa cos 26 degrees is equal to adjacent over hypotenuse, which is Vx over Vi, and if we actually rearrange the formula, we get 18 cos 26 degrees equal to Vx. And similarly with Vy initial, sine 26.0 degree equals to opposite over hypotenuse, which is Vyi over Vi, and that is equal to 18 sine 26.0 degrees. So if we actually calculate it, 18 cos 26 is equal to, it's roughly equal to 16.2 meters per second, and 18 sine 26 degree is equal to 7.89 meters per second. Okay, now we have everything calculated. So let's look at the question. It said, what is the maximum height reached by the projectile? So if we actually think about it, the projectile is going to fly like this. But there is going to be Vx, right? However, at some point, Vy, which is going up, will stop around here because it needs to go down. The ball is going down due to gravity. So actually, if we let Vyf equal to 0 meters per second at the highest level of the projectile, we can find the maximum height. So what we can do is, let's redraw the picture. Let this equal to the maximum height, which is dy, and we can let velocity here equal to Vyf. Also, one more thing that we have to be careful about is that since x and y components are involved in this type of problem, we cannot add or subtract, divide, multiply different components. We can only multiply or divide, add, subtract like variables, which means y components with y components only, x components with x components only. However, one thing we can use in common is time. Time has no variable assigned to it. Okay, so let's solve this problem. So what here, Vyf is going to be 0 meters per second. And here, Vy initial is 7.89 meters per second. And the gravity is pulling the projectile downwards, which means gravity is, this is actually y. This is y component. So we're going to use this formula 3f squared equals 3 initial square plus 2ad, where d equals to the maximum height. So if we actually rearrange the formula, it'd be easier. 3f and if we actually rearrange it one more time, we get and since we know that v final is 0 meters per second squared, we can just ignore that and work with this. If we actually solve this problem, here, let me erase these. We are going to get minus and remember, acceleration is always negative. Therefore, maximum height is .2 meters.